does one of his last videos on Danfoss VLT drives. This is going to be part 2 of control of the drive with a pressure transducer. So I have two screens fired up. You can see on the one screen I've got my LCP mounted in my high-tech compartment with the D9 cable, and showing you that we're auto remote and we're on standby mode. I have a set of refrigeration gauges as well, and I've got my pressure transducer screwed into the center port, which you can't see. Well, I'll just move it. And it's onto the center port of our refrigeration gauges. And if you don't know how they work, it's not a complicated thing. There's two hand valves, and this one in red on the right-hand side goes straight through to the gauge, and you can see that I've got over 100 pounds of pressure from my nitrogen bottle. And there's a tap on the right-hand side which opens up a port right here inside. So when I roll that tap open on the right-hand side, it's going to take pressure and put it onto the pressure transducer. And if I want to see it, what that pressure is, I'm not hooking my low side gauge to a refrigeration system, the blue hose. If I did and I wanted to see the low side gauge pressure, then I would not open the low side, the left side tap, and I would see the low side pressure right straight through to the gauge, and I would see my high side pressure right straight to the gauge from the red hose. So I'm just using this as an easy, convenient place to throttle the pressure from the nitrogen bottle to show you what's going to happen to our signal from the nitrogen. So what I will do eventually is I'll open up the red end tap on the right hand side and basically open up the tap on the left hand side to put pressure so that you can see what the actual pressure is on this low side gauge. Okay, so that's my plan. I have it open now, actually, in fact, so there. That's the plan that I have for doing a readout. So go to the screen now, and with my Word document, and you can see now we're just going to wire in two things. Very simple. We're going to wire in, I've got a low voltage terminal wire coming out of the control box. It's just a digital signal. It's a forward reverse switch. I'm just going to use one normally open switch, and I'm going to put it across 12 and 18 on the terminal strip inside the frequency drive. And for my students, that would be wire number 4. And now we're going to wire in the transducer. And you can see that the brown wire from that M12 wire is going to go across 13. That's my power source. And the white wire is going to go to terminal number 53, which will be the variable input from 4 to 20 milliamps. All right. Another thing that's not so obvious to see is I've got to convert the accepted input signal from voltage, which is U, to I, which is current, milliamps. So you can see that right here. And there's a dip switch, and it shows you that it's right below the face of the D9 plug on the actual frequency drive. And it's not easy to find. It's just, you look around a bit, you pull the LCP off, you look at the bottom right below where it was plugged in, and you'll see two switches. One's for A53, analog 53 input, and analog 54 input. So they have been defaulted from the factory to U, which just stands for voltage with our European friends. And just got to take a little screwdriver and click it over to the right, and it doesn't move far. Click it over to the right to accept an amperage signal, a milliamp signal, in fact. So that's one thing you have to do to make this work. And here are all my parameters. Feedback source, which we did before, was an analog into number 53, 20-0. And again, it's already completed. I've done all these things. The small line on the display LCP to be RPM. And then we have to go into the motor speed units. We're going to change it to RPM as well. So these are all pretty much standard, easy things to do, and we've done them already in my other videos. Here we have to change the reference site. In other words, the signal, which What's it going to do? Does it need to be hand? Does it need to be linked to auto? Obviously, we want it in remote so that when we hit the auto on and give it a digital command from my little switch, it's going to run based on the current draw, or current output, I apologize, of my transducer. Okay, so these are all pretty straightforward things to do. Maybe not so straightforward. You have to go into 610 and tell it the minimum and maximum when it needs to move. And then if you keep scrolling through parameter 6, it then says, hey, what do you want to do for the RPM? So if you had a motor that you didn't want to go and start at 0, you want it to start at, say, 600 RPM, which, again, you have to be cautious of sleeve-bearing motors versus ball-bearing motors. Sleeve-bearing motors have to be brought to their full RPM first to get the oil out of the babbitt onto the bearing. So that's why traditionally more and more motors are ball-bearing, which don't care the minimum and maximum. And so that's essentially, that should probably be changed, reference to 1800. It should be changed to 1725 as well, which doesn't really matter to me. And then change our ramp up, ramp down times. It doesn't need to be instantaneous responsive. It can be, because we're gonna, like mostly in the real world, we're gonna measure the suction pressure or the head pressure. We don't have a PI bid loop on this at all. And here's my one fault. I just looked at it, viewing this, and that should be auto on, should be the command. And I know that because I'm looking at the other screen as we speak. And away we go. So go to my LCP screen now and my gauges to see the pressure. I'll use a screwdriver or a pencil right here. You can see the pressure from my nitrogen, not easily, but it's over 100 pounds. These are 410 gauges, so you don't move the needle very much with our 410 gauges. I should use my R12 gauges. I have some kicking around here. And you can see there's no pressure on the transducer, and this tap on the left is open. So what I'm going to do is hit the forward reverse digital input to on, and now you can hear the drive is running, take my word for it, and it's at 197 RPM up here at 6.6 hertz, and it scales it to that. And it's turning because the minimum output of the transducer is 4 milliamps. So it's turning at 11.4%. That's where it's at, because 0 to 420 is essentially what it's looking at. So what we're going to do then is we're just going to just give it a little bit of gas pressure over to the low side, and so my low side pressure is around, I'll call it somewhere around 70 pounds, 60 pounds. And now the motor is up higher into its RPM. So that's going to basically try and control my head pressure per se. And don't forget, you got to use the correct transducer if you're doing higher pressure refrigerants. Even this transducer we're using would probably be well suited for superheat controllers and that kind of devices on the low side. I know this transducer does not work with 407, 410A superheat controllers because the pressure is a heck of a lot higher. So if I roll my pressure up a little bit to a higher value, you can see on my LCP, I'm up at 100%. I'm almost topping out at 57.5 hertz. And I've set the maximum RPM in the limits to 1725. And that's what it's turning at. So I'll just close off the gas pressure to the low side from the high side. And then slowly bleed this down. I need more hands here. And watch here at my status as to my percentage of the full scale. And that's not reacting very fast because I have 10 seconds down, 10 seconds ramping down and ramping up. So that's why it's a little slower on the draw. You could have it a lot faster. I don't see a requirement for that. But like big fans, etc., you want to stay away from too fast a response for up or down, because obviously there's a lot of work going on and you could blow the brains out of the frequency drive if you asked it to control it down without brakes, etc., heater somewhere to deflect the excess energy that's coming back to the drive. This is obviously just a small application, so I'll just keep bleeding it off. There, I'm at, looks like, I'm going to say somewhere around maybe 10, 15 pounds of pressure. So we're still not down at the low end of the scale, but you get the idea. You want it to go faster, then we watch the head pressure would climb because the fans aren't on, and the fans eventually come on, and it brings my fan motor to the maximum RPM, trying to maintain X amount of pounds of head pressure. When I bleed the pressure off, he says with a grin, pressure's going to fall, so does my output from my transducer, and eventually it goes down to the minimum 10 hertz. And obviously the command for calling is, I have it as a digital switch, but obviously you'd want a command, say, from a relay, from a thermostat, calling for cooling, calling for heating, whatever the case may be, and then it's running on the reference now, which is almost the minimum that it would run at. I'll just bleed it all off. There you go. That's the lowest it's going to go down to. And again, you can get rid of that by changing that value to the minimum. Okay? And I'll just take my switch, open it up, and now you can see it's quit and it's on auto remote. It's on standby, waiting for a command. Kind of cool. I'll just show you one other thing here before I go. I can open up the pressure on the gauges to put pressure to the transducer, and without anything running, you can see that the percentage of it is seeing a command. That's why I knew I had it wired in right. When I finally put pressure to this low gauge, or the transducer, in other words, you could see that it did go to 100%, even though it's not asking to do anything. So with a command to call for cooling, it's ramping up over 10 seconds to get to the 60 hertz status. Pretty cool. And again, ask it to stop. There it goes. Trying to maintain pressure. Pretty straightforward. Requires a little bit of fiddling around, but it's a pretty cool idea. I'm out 13 minutes.